Hello everyone, and welcome to today's workshop, Marine Data for Ocean Health for the Copernicus Marine Service. So my name is Gail Enav-Sterbik, and I'm a training officer at Mercator Ocean International, and I'll be your host for today. So as you know, we will have a two-day workshop, and today we will have an introductory session, where we'll tell you about what the Copernicus service is about and what sort of data you can find, and also what sort of application you can do with the data we provide to you. So before we start, we are going to go through some house rules and guidelines to help you follow this workshop in the best possible way. So first, please try to not use the chat that you see on your right-hand side for your question. You can use it for small talk or to say hello to us or to discuss with each other. But if you have a more technical question or if you have any other type of question, you can use the Q&A button on the website. So you can find it here. So it's on the top bar. You have the Q&A section, and you click on it, you will see the area dedicated to the Q&A, and that's where you can ask our speakers your questions today. We will also put the link in the chat for you to use if you can't find the button for some reason. And next to it, you will also find a survey about the workshop that you can answer at any time. So you can also do that if you want. It would be really helpful. And so for today, concerning the agenda, so we will have many interesting presentations. So we will start with an overview of the Copernicus Marine Service that I will give to you. And then we will have a demonstration of the visualization tool, which is MyOceanPro viewer by Anaïs Perrin from Mercator Ocean. And then we will have Quentin Hivernat that will present his work on data assimilation and optimization at Mercator Ocean. And after a short break, we will have 3 presentations about specific applications of these Copernicus marine products. So we will have Giuseppe Aulicino from the University of Naples. Then we will have Georgios Sylaios from the University of Stras. And finally, we will have Diego Panzeri from the National Institute of Oceanography and Applied Geophysics. So the 3 of them will give us presentation of their works using the Copernicus marine data. So it promises to be a very interesting morning, and I hope you enjoy it. So now we will jump right through the third presentation, which is a little overview about what the Copernicus Marine Service is about. So it's just to introduce you to it if you are not familiar with the service yet. So Copernicus is a program created by the European Union. So it's a European fully funded program dedicated to the observation of the Earth and to better understand different systems of the planet. So it includes 6 services. So the atmosphere, marine, land, climate change, emergency management, and security services. And all of these services provides information and free of charge open source data products about all of these different systems of the Earth. So obviously the marine service focus on monitoring the marine environment. To access the service, you can use the website of Copernicus Marine. So it's free to access the website and to download any product. You just need to have an account, and there you will find an extensive catalog of products, and all of them are scientifically qualified and they are user-driven, so they are constantly upgraded and improved. And we also take into account the experiences of users of the service. So what kind of data the Copernicus Marine Service provide? It provides data on the blue, green, and white ocean. So the blue is all about the physical component of the ocean. So it's everything that has to do with currents, temperature, waves, wind, sea level. The green ocean is the biogeochemical component of the ocean, so everything from phytoplankton to nutrient and oxygen and everything. And the last one, the white ocean, is all about ice, so ice coverage, ice velocity, ice concentration. You can find these are just a few examples, and in terms of temporal and geographical coverage and type of data, you have a lot of choice. So it includes in situ data, satellites observation, which are used to validate model data, and then you can also find data that are measured right now, so real-time data. There is also reanalysis and multi-year data that goes from the past all the way back to 30 years. And then there is also forecast, which are 10 days into the future. And in terms of geographical coverage, we do cover 5 areas or 6 regions. So we have the global region, which is all around the world, and a few smaller areas around Europe. You will also find on the Copernicus Marine Service website a visualization tool that we call MyOceanViewer. So there are 3 versions of it, the MyOcean Learn, MyOcean Lite, and MyOceanPro, which is the one we will have a demonstration after my presentation. So it will be a nice presentation, and it's a very useful tool, and it's a very fun way to visualize a product or just see the data on a map. We also provide specific products like ocean monitoring indicators or data related to the climate. In this case, the monitoring indicators are key variables that help us understand how the ocean is now or how the health of the ocean is. And they are also accessible and free of charge, and they cover the past 30 years, so it's long-term analysis. Beside data, we also provide information, and one of the ways we do that is by publishing a yearly report on the state of the ocean. You may have heard of it, so it's called the Ocean State Report Summary. And we try to target more or less scientific communities, and so like more policymakers or the media or just the general public. And also to make sure that the information is getting to everyone, we created 2 pages called the Ocean Explainer and the Ocean Climate Portal. So it's where we explain some oceanographic concept or current threat that the ocean is facing, and we try to explain it to everyone. So yeah, that's it, more for general public. And also the Ocean Climate Portal just gives a perspective on the indicators, key variables of the climate and the ocean, but also in a more accessible way for everyone. So as you can see, we try to reach a bit of everyone, so scientific community and general public. And it's the data that we provide and the information, so it responds to different needs and markets. So that's what we call the blue markets. It goes from science to innovation and also covers policies, coastal services, and economy sectors. And for example, also today you will hear about 3 practical applications of the data, but on our website you will find many more examples, and we invite you to visit the website and learn from this example. And also, if you are a use case yourself and you use Copernicus Marine data in your work, we also invite you to submit your project as a use case. It's always very nice to see what the data are used for and to see and to make it available to everyone. And beside all of these different things we provide, we also try to make sure the data is not only available, but also we can help people use it. So as you can see, we organize workshops and webinars like this one, but we also organize hackathons and forums and other events to try to engage with the users. So there is a bit of everything for everyone. And that's all for me for today. So I hope you got a little glimpse of what the service is about, and I will let Anaïs do the MyOceanViewer demonstration.
Hi everyone. I will start to share my screen. Okay. Hi, I'm Anaïs. I'm a member of the Copernicus Marine User Support Team. And during this presentation, I will introduce you the different features of our data visualization tool, MyOceanPro. So to access the MyOcean Viewer from the home page, simply scroll down and click on Try Now into the Dive into our digital ocean box. So here you have our three different ocean viewers, the MyOcean Learn, the MyOcean Lite, and the MyOcean Pro, which is the most advanced and the one we are introducing here. So when you first open the MyOcean Pro, you will see the interface displaying default layers like the seawater velocity, the potential temperature, and the concentration of the chlorophyll A. The little blue eye next to the layers and name indicates that the layers is visible. You can choose to hide it or display another by or even change a priority order by dragging them up or down like this. By hovering your mouse over the variable's name, you have access to the details information about the product name, dataset, and the variable itself. On the interface, you can also change the projection by clicking on these arrows for the North Pole projections, for example. That's it. And the South Pole projection here. So you can also click and drag the map. You can zoom in and out using your mouse wheel. In today's example, we'll be looking at an area to avoid the effects of upwellings and anthropogenic inputs as far as possible. So let's take an oligotrophic waters of Hawaii, for example, and look at the nitrate and the chlorophyll A data. So to find the product, we need simply click on Add Layer here. This takes us to the Copernicus Marine Data Store, where near 300 products are available. So these products are classified in various ways. The most popular, the recently opened on the MyOcean, new in Copernicus Marine, and so on. Under each subsnail, you will find information about the product. So the product name, the data acquisition mode, its model or satellite, for example. You also have the spatial resolution, the number of the depth level if it's three-dimensional. Satellites are generally in two dimensions. You have the temporal resolution and the variables. The filters column on your left lets you refine your search by entering keywords, specifying the desired time range, three-dimensional data with the depth, selecting the type of variable, and specifying the geographic area, and many other parameters. In our case, we are looking for nitrate data with a good resolution for our study area. We choose the nutrient variable in the main variables and pick up an area that include our sector, like global. Next, I will click on a numericals model in the source section. Our filters return the product that can meet our needs. So click on the product, redirects you to the product description page, which provide an overview and useful details such as the full name, the product ID, the variables, and so on in the classification section. On the left, you will have other tabs like notifications that tracks incidents, improvements, and maintenance, current or past. The data access tabs show you all the data sets in the project and explain different download modes. For each data set, you will find links to the service currently variables, subset files and maps. By clicking on the small button, you arrive directly on the articles of our App Center by linking with the chosen access mode. And these articles are there to explain how these download modes work. The contact tabs allows you to contact the Help Center, and then the documentation section, you have the links to the user manual, the quality information document, sentences quality overview, product quality dashboard, roadmap, license, and articles on how to cite the project. The user manual contains all the technical information relating to the product, while the quality information documents provide scientific details and information about the data acquisition modes. The DOI links redirects you to the project description page from our catalog. And if you wish, you can share the project page via the share icon on the top right, which copies its URL address. So to visualize a project's variables, click on Add to Map, and then select the variables of interest from the various datasets variable. The dataset nomenclatures indicates the type of data it contains, and the suffix indicates its temporal resolution. D means daily, and M means monthly. So here, only dataset corresponding to the filters used previously are visible. To see all the dataset and variable, click on All Layer. So I therefore choose the daily dataset showing the nitrate concentration. I click on Add to Map. You may remove any layer you don't need by clicking on the cross here. So you will see 5 small icons under each layer: the download icon to download the data, the information icon returns you to the product description page. The layer icon here is to change the open variable to another on the same product. For example, the project containing the current variables also has several other datasets with different time resolution for other variables. For example, the salinity datasets with the 6 hours, 6 hours here. So the gear icon here is to customize the layer, and the log icon to apply a logarithmic scale. The gear icon lets you to change the appearance of the layers. You can adjust the opacity of the layer. You can also change the color map, adjust the color scale inversion. You can also use a discrete color step. You can add, delete, or redefine the steps. You can also change the minimum and the maximum values, for example, here, and whether or not to hide the outbound layers, like this. Use the auto button here to automatically set the minimum and the maximum values based on the current map view. So for vectors data, like current here, you can change the display style to just solid, solid plus particle, solid plus vector, only particles, or only vectors. So the appearance of the particles for vectorizable dataset has recently been implemented, and for greater visibility, we will only show these particles. So the bar at the bottom of your screen shows the time range for which data is visible. The weightest lines indicate the common data availability for all the open layers. You can zoom in and out using your mouse wheel. You can also use the right and left arrow on your keyboard to step through time, here day by day. On the right side here, under the objects and settings, there is a depth scale. This appears because we're viewing three-dimensional data set. So by default, only surface data is shown. But you can click on the scale or use your mouse wheel to display the data at deeper. Can also use the up and down arrow on your keyboard to display the deepest level in increments of 10 meters. So above the depth scale, you can create some objects like point here, lines, or an area. Like this, for example. So each graph show you its coordinates. Transect length for linear object and area surface for area object. The values of the open variables and an average of the values for lines and area. So also, but also the minimum and the maximum values of these objects. So each object generates graph, time series of or depth profiles for three-dimensional data. You can access graph option via the three small dots on the top right-hand corner of each graph. You can adjust graph and you can set the start and end dates. You can also download the graph in NetCDF, CSV, and SVG format. You can remove the graph or add another if you need it. Up. And I will just remove it. Under the object creation, you will see the import features. So it lets you import geometries into the viewer. You have access to predefined geometries. The recent tab is a shortcut to the recently opened geometries. You can also represent a geometry in a well-known text for geographic information system, import GeoJSON or shapefiles. So for example, let's take a look at the marine ecoregion, including Hawaii. So I search for Hawaii here and import it into my visualization. So as the area across the antemeridian, the objects are split into pieces. That's it. Not when you download the data from an object, it's download everything within the rectangle bounding that object and not just the object's exact shape. You can, or another feature is the ability to combine objects. This is very useful for comparing data from different regions in the single view. And under the import option, you will see settings for logged in, logged out, change the base map color, show toponyms, changing the projection and settings, units for objects, and so more. So now let's see how to download data. So you must be logged in to download. As a reminder, the registration is free. If you are not logged in, the viewer will prompt you to do so. So click on the download icon on the variable you want. The geographical area, in this area, you can either type coordinates manually or use the define on map option. You can draw your area of interest directly on the map like this, or you can also select an existing object. The time range must be within the time period shown here in gray on the side. You can use the as in map option to automatically use the currently view date range. For example, the depth range is only visible for three-dimensional datasets, so you can enter the range of interest here or use the as in map option. The section also download allows you to download several variables contained in the dataset at the same time. So when you're ready, the download buttons allows you to directly download your parameterized from the MyOcean interface with a limit of 800 megabytes. The automate buttons allows you to override the 800 megabytes limit using the Copernicus Marine Toolbox. Two download templates are proposed, one executable from the command line interface and another from the Python interface. The browse file option is for retrieve the original files as distributed by the producers, organized typically by years, month, and the day. So these files contains all the variables for the entire geographical area concerned at the date. So these files are not subsets. If you encounter any difficulties, you can contact the Help Center by clicking on the small bubble at the top, Talk to an Expert. The widget will then open, and in Message tab, you can ask your question. Blue, our artificial intelligence companion, will use our knowledge base and articles to answer your question. You can always opt to contact the human support team member if Blue answer doesn't address your issues. If there is a problem, especially with the downloading data, please copy and paste the download template you generated from command line or Python, whatever, so the support team can investigate. So you can also consult the Help Center articles without leaving your page by going on the Help tab. For instance, if you're looking for information on how to use MyOcean Viewer, simply type MyOcean. And in our introductory MyOcean article here, you will find a section, a Q&A section here that may be great of use to you. The MyOcean also has a sharing feature accessible via the share icon. So you can share the current visualization. You can create an image or even a video. You can also generate an embed link to include it on your own website or platform. So finally, there is an information icon that details all the keyboard shortcuts you can use on the MyOcean. These shortcuts can make your navigation and data exploration quicker and smoother. And several articles are available in our Help Center about the MyOcean Viewer and much more. The user support team is always there to answer your question and to help you if you encounter difficulties. So thank you for your attention.
Thanks a lot, Anais, for your nice and complete presentation. We have a few questions for you. So we are going to go through the Q&A section. Thanks a lot. So the first question, is it possible to get an API of specific data viewer for my website? Can the API start at a specific waters of a specific country?
It's not an API, but for the moment, you can just, oh, sorry, I will share my screen again. Okay, that's it. So for the moment, the only thing you can do for sharing is use the embed link for using the MyOcean in your website or project. But we don't have an API for the MyOcean viewer, but you can use the toolbox or other tools to use the data. But you can contact the Help Center, and my colleagues will answer your question.
Thanks a lot. Okay, we'll go back to the question. The next one is there an index overview of all the providers of data and instrumentation used to provide the products in CMEMS? I know there is a detail in each product, but I don't know if there is an overview of all the providers.
No, I don't think so. An overview of all providers of data. But we have different families of products, global, EB, Baltic, from different providers. But I don't think we have an overview of all the providers named for each products.
No, I don't think so either. I think we have to go on the project and check what is written in it. This question, this website looks very familiar to Giovanni Jesdik of NASA. Is it from the same data structure? I don't know if you know that.
No,
No.
sorry,
Okay.
I can't answer it.
Okay, I will put the question aside to have someone answer if someone know, and I will put the question and the answer in the post-event report. Okay. This question, so is there a way to download data using geometries in the Copernicus Marine Toolbox? With the Python API, I only see min, max, lon, lat keywords.
In the way to download using geometries, yeah, you can make geometries. So with the import feature, you can use a well-known text or import your GeoJSON, your shapefile, or create your area directly on the map, and then you can download the data on these geometries. So you can make your calcul and Python work after all. Or you can also download the data of the graph generated in the MyOcean viewer. Yes, we Python API. So first of all, I recommend to download the data you want with the viewer, and then you can open your data on the Python and see all the information you want.
Thanks a lot. So we have this question and a similar question. So asking, so this one, let's say you want the data from the year 2001 for this nutrient. Is this possible?
Yeah, sure. Yeah, with the filters, you can set the start date, like 2001, and choose the nutrient. And you have, for example, the the product 001 02 29 is a global product for biological data, and his data from 1993, I think. So with the filters, you can find your product.
Yeah, it's what it seems to me. Thanks a lot. We also have a few questions, so several the same question. What format is the data download?
Format is an etcdf by default. You can also download the CSV or SVG data format, and with the toolbox you can also download data in a ZAR format, and we have an article on that in the Help Center.
Thanks a lot. This question, what is the programming language used to analyze the ocean data using MyOcean Viewer? Are the results justifiable?
So I'm not I don't have implemented the viewer, so I don't have the answer of your question, but we can take a note of your question, and you can contact the Help Center, and we can back to you with the answer.
Okay. This question asking, so you mentioned Python, but can we also read downloaded dataset with R? Yes.
Yeah, read the function read data frame, read open data with the Python. The toolbox have a function read open data set. Sorry, but I don't think that this work on R, but the developers work on it. But for the moment, you can open the data set remotely using this function. But Friday, I will take a presentation of the toolbox, and I will make a demonstration of all the functions of the toolbox. So, so that's it.
Come back Friday.
Yeah.
Come back Friday. Okay, thanks a lot. We have this question. Please, can we find this data and work in cloud with Google Earth Engine?
I don't know. Sorry.
I think we often have this question, and we don't always know the answer, but I will put the question on the side to provide a better answer also for the post-event report. So next question, does CMEMS provide information related to sea level rise according to IPCC projection under climate change scenario? Yeah, we have several questions about data projected on the future for this kind of use. But yeah, we have the forecast data, but it's 10 days into the future. I don't know if we can use the data to try to match the IPCC projection, maybe.
Perhaps we have some data in the sea level, sure, but under IPCC projection, I don't know why. I don't know why. What is it?
It's for the GIEC.
Oh, okay.
The scenarios. Sorry, but no, I think it's just like short forecast. So you will have to work if you want to do IPCC projection with CMEMS data. Okay. Okay, so I have lots of questions. Okay, so this one, I will put this one. Is there data about water density in different parts of the ocean?
Water density, yeah. We have some product that have these variables. Just use the filters option, and you will retrieve the data set. And if you can't reach it, contact the help center.
Okay, thanks. So we have time for 2 more questions quickly. So can this data be used to describe some of the conditions of Smile Island? What is the accuracy of the data for specific location? It depends on the areas you want to study.
The areas and the product. So we invite you to read the document of the product, the user manual or the quality information document. And in this document, you have all the information relating to the data acquisition mode. And if you have a more question, please contact the help center.
And just one last question. Those CMMs have downscales, projections, data.
I don't know. I don't think.
We will have a look. We go back to you. We put the question on the side.
That's
Because
it.
I'm not sure at all. So
I don't think so.
Okay, so we have a lot of unanswered questions. Don't worry, they will all be put on the side and answers, and we will put everything in a post-event report and send it to you with the replays, the PDF presentation, and everything. You will receive an email to let you know about that. So thanks again for all of your questions. Thanks again, Anaïs, for your demonstration.
Thanks all.
And yeah, so we can go to the next presentation. So Quentin, for your presentation about assimilation of Siemens data. So welcome.
Yeah, hi.
And whenever you want, the floor is yours.
Perfect. So first, hello everyone. My name is Quentin Iverna. I'm PhD student affiliated with both Mercator Oceans International and LOVE for Laboratoire de Sonography de Villefranche-sur-Mer. My supervisors are Alexandre Mignot at Mercator Oceans and Fabrizio Tetenzio at LOVE. And today I will present you how I use the Siemens data to improve the parameter from a biochemicals model. And it is my PhD work. Yes. Up, 1 second, please. Yes, perfect. Firstly, the Siemens provide data set derived from observations in situ or otherwise, as well as data from numerical models. To introduce the problematic of my thesis, I present here 2 Siemens products of the partial pressure of CO2, or PCO2 for short. To note that the flux of CO2 between the atmosphere and the oceans depends directly on this PCO2 value, making it one of the key variables for the climate modeling. So first, on the left, we have a 3 years average, 3-year average of a product based on observations from the Siemens product. And on the right, we have the result of an EB simulations, which is a configurations of the Nemo-Pisces model comparable to the product implemented in Siemens. The EB model is a high spatial and temporal resolutions, a regional model of the North Atlantic, and whose domain is represented here. I have then represented on the right on this time series the seasonal variations of PCO2 from these 2 sets of Siemens product. And we can easily see a big differences between these 2 products. So we have the observations of the Siemens observations in blue, with the error of observations in the blue envelope, and we have the EB configurations in red. I have also plotted in orange the seasonal variations in PCO2 from the Siemens global biochemical model, and we can see that its model also fails to represent the correct seasonal variations of PCO2. Sorry. It takes some time.
You can try with the arrows on your keyboard also, it should work.
Yeah. Yes, it's more efficient. Sorry. Moreover, Roger et al. Recently showed that these poor representations of seasonal CO2, pressure pressures of CO2 variations, particularly in the North Atlantic, was represented in all the semipsis model. A semipsis model is a state-of-the-art model from different countries. This is shown in the figure on the left, taken from Roger et al. We have the observations here in blue. It's the same of the cement product in blue here. And we have the semipsis models represented in green here. And we can see they obtain the same results of the cement numerical models in red and orange here. So you can observe a huge gap between observations in semipsis model. And the aim of my PhD is to answer at your questions: can the biochemical models be optimized to represent seasonal variations in P2? Yes, it's my feature. To answer at these questions, we need to know that into a biochemical models represents the biochemical processes are described by empirical relationships. There are mathematical formations involving one or more parameters. And these parameters are often derived from laboratory experiments and rather from in situ observations. Moreover, these models typically use a single set of parameters for the entire global oceans, despite its complexity and diversity. This leads to significant uncertainties in model predictions. So, as a result, we observe fairly strong bias between observations and model. Our hypothesis is that this bias is due in particular to the uncertainties in this parameter value. This is what we have shown here in this first figure. Consequently, our objective is to optimize these simulations, these parameters, in order to produce new simulations with lower bias than the reference simulations. To do this, we are going to use observations to force the simulations, to use observations to force the simulations to become increasingly accurate. Yes. For an efficient optimization of parameter method, we need a lot of observations, and preferably we need simultaneous observations of several key variables. PGC arcofloats are ideal for this purpose, providing multiple in situ observations with vertical and temporal height resolutions. To achieve this, the floats shown here are fit with multiple sensors before being dropped up into the sea and dived down to 1,000 meters to observe the entire water column. After several days, they return to the surface to transmit its data. So these floats typically measure a variable essential to biochemical models, such as chlorophyll A, particulate organic carbon, the dissolved oxygen, and the nitrate concentrations. Additionally, prediction from the Canyon B, its a neural network, enable estimate of silicate, phosphate, dissolved inorganic carbon, and alkalinity. These observations come from both Coriolis and the Siemens database. And I represent here the ID of the Siemens database. So to reduce the bias, the bias. In modeling the seasonal variations of PCO2 in the North Atlantic, we will use observations from a float, so a biochemical arco-float, that has been profiling in the North Atlantic for 1 year. But also for our optimization method, we will use different data sets from the cements. First, we need to retrieve files of some physical variables at the same spatial locations as the observations from the float. To do this, we will use the output of the cements global models, which distribute temperature, salinity, and density among other variables. So on the right, I have shown the vertical cross-sections of these variables from the cements model, which I compare the observations from the float in the North Atlantic. So we can observe the temperature to the surface to 1,000 meters, the temperature, the salinity, and the density from the cements model, numerical models, and the temperature, salinity, and density observed by the biochemical float. And we can validate easily the accuracy of the physical numerical model of cements. After that, we also need simulations results from the cements global biochemical models to initiate the simulations required in our parameter optimizations, shown here with the data set ID. Using the results of the two numerical models distributed by the cements above, we will be able to run our simulations, which is necessary to carry out our parameter optimizations method. After that, to be able to compare the results of our own simulations, our own Nemo-Pisces simulations, with the observation from the biochemical arco-float, we then need to average them in the same vertical layer. To do this, we need to recover observation of the aphotic depth. So we have therefore used the KD 490 observation from the cement database represented here. Thanks to this KD 490 observations, we were able to estimate the depth of the aphotic layer. This is necessary in our method to compare the output of the simulations with the observations of the biochemical arco-float. Yes. So thanks to all the previously used dataset, we are able to apply our parameter optimizations method. And at the end of these optimizations, we found the 10 parameter set that best fits the observations of the biochemical arco-float. We now need to test this new optimized parameter set on a height 3D Nemo-Pisces model. To do this, we run an ensemble of 10 EB simulations. Each of these simulations contains a unique set of optimized parameters. We also run a simulation with the reference parameter set to compare the result obtained with the reference name list. Each of these simulations will run for 3 years, to 2021 to 2023. And at the end, we need to validate these new simulations. For that, I use observations of the chlorophyll A from the cements product, the cements observations, satellite observations, and I average these observations on this map for a 3 years period, to 2021 to 2023. It's the maps I've shown here on the left. And I compare these observations with the reference model of EB and with our ensemble mean or model optimized. And I have also plotted on the right the bias obtained by the reference simulations compared to the observations and the normalized bias obtained by our ensemble mean compared to the observations. So the closer the bias is to 0, the closer the simulations is to the observations of chlorophylla. And we can observe we obtain very good result. And I resume this figure on these two value, and we can see our ensemble average, our ensemble optimized, obtain very low bias in comparisons with the reference simulations. After that, I need to validate our ensemble optimized simulations with a variable we have not assimilated for our optimizations method. For that, I take another observations from the cement database. It's the concentrations, it's the pH value, and also I have also average the concentrations in 3 years. It's the map we can see on the left. It's the observations of pH, and we have also the reference model and the ensemble mean of pH. And I have also represented here the bias obtained by the reference simulations compared to the observations, and the bias obtained by our ensemble mean compared to the observations segments. And we can also see we obtain a lower bias in comparisons to the reference simulations. Yes. So we can answer at the questions I have put at the beginning of my presentations. For that, I do the same as before. I take observation from the cement dataset of PHO2 represented here, and I have also compute the mean of our ensemble optimized represented here. And after that, I compute the time series obtained by our ensemble mean. It's the green line here with the standard versions of our ensemble represented in the green envelope. So we have the observations in blue, we have the reference simulations in red, and we have also our optimized ensemble in green. And we can see we recover the good phenology of PCO2. Our ensemble can simulate the seasonal accurate seasonal variations of PHO2, and it's something of the semipsis model can able to do, like Roger et al. Showed before. So our ensemble produces the correct phenology of PHO2, and after I have also compute the bias normalized obtained by our ensemble mean compared to the observations, and we can see we obtain a very low bias in the PHO2 in comparison with the reference model. So our ensemble produced the correct phenology of the seasonal variations of PHO2, but also it obtain a very low bias of this PHO2 compared to the observations from the cement database. To summarize, we have developed a method that allows us to simulate the correct seasonal variations of PHO2 with reducing the bias on several variables. Additionally, this method allows us to estimate the uncertainties in these simulations. To do this, we use 6 cement products I have shown before during my presentations, and I have put their ID here. So we have some numerical models, some satellite observations, and also in situ observations with the PGC Argo flood. And it's done. If you have any questions.
Thanks a lot, Quentin, for your nice presentation. So it was really interesting to see that. We don't have any question for now, so we can maybe wait a few seconds to see, but if nothing comes, we will go on the break. Okay. So, yes, we have one question coming up.
Yeah.
So, how the data is collected based on observation and in situ observation?
It's based on observation. Oh, I download the data from the Siemens database, or they are only collect by the biochemical Argo floats.
Yeah, I think it's more like if you know if it's from Argo floats or from boat or something like that.
Yeah. For the data I use for assimilate during my parameter optimization method, I use the biochemical Argo float observations, and it's very it depends of the sensor, sure, but it's in situ observations. It's the sensor fit in the biochemical Argo, and this biochemical Argo type to one food sense method, so it's in situ observations.
Thanks a lot for the explanation. Next question being, you showed the performance related to PCO2, but I would like to know if you checked the other key BGC parameters as well.
Yeah, I have also checked the primary productions integrated across the vertical profile with another cement product. I have also checked with other biochemical Argo in the EP domain to so the nitrate, oxygen, chlorophyll, and yeah, at each time we obtain good results. And I have also compared with WOA climatology. So with nitrate, phosphate, silicate, and dissolved oxygen. So yeah, I've shown here the PCO2 variables, but I have also checked other key parameter, biochemical parameters. Not all, because we have not good observations for all these parameters, but yeah.
Okay, thanks a lot. A few questions related to the paper. So the first one being, what is the title of the paper?
It's Roger et al. And if maybe 1 second, I have up. If I can show you, no, it's too, yes. It's seasonal variability of the surface ocean carbon cycle synthesis.
Okay, thanks a lot. We will also put the question on the site to put the link for everyone on the post-event report. Thanks a lot. Okay. These two questions speak about the methodology. So what is the difference between the models you pose with BGC Argo and the Copernicus data, and also any methodology or PDF related to it collecting of observation?
So the first, the difference between the my EB configurations and the Copernicus data of the EB simulations is it's not a lot wide differences. We have only I have not put the reverse, and I have another small processes I don't have, and the Copernicus data of EB simulations have. So it's these two simulations are very comparable. It's not the same, but it's very comparable.
Okay, thanks a lot. Okay. So for this question about methodology, I guess the paper should answer all of the question. Okay, next question. For some of your graphics, it looks like there are systematic temporal errors between the prediction and the observed values. The graphs are shifted in time. Why?
It looks like, yeah. Ah, I don't know. It's not easier to answer a few questions. In the paper Roger et al., they have shown that there are a lot of processes. It's I think you speak about the P202 time series, and uh, for for a lot of models, there's the P202 variabilities. It's controlled by the physical processes, and so we have shift. When it's the case, that shift the P202 in time, where the P202 variability is not in phase with the observations. And with our optimizations method, we can recalibrate their processes, and we can put in accurate phase the variability on P202. It's there are a lot of processes impacts P202 time series variabilities.
Okay, thanks a lot for the explanation. We will do one more question. So this one being, have you used any machine learning model to correct bias between observations and models?
No, it's not machine learning method. It's optimizations method called particle filter. It's not a machine learning method. It's a little similar, but it's not the same. And so with this particle filter method, we have only optimized the parameter values for improved the models. So and it is this improvement of model to at the end correct the bias between observations and models.
Okay, thanks a lot for the question. So we have a few that we didn't have time to answer, but as we said previously, we will put everything in the post-event report, so no worries. Thanks again, Quentin, for your nice presentation and your participation.
You're welcome.
We will move to the small break, so a small 10-minute breaks, and we will be back in 10 minutes for the rest of the presentation. Don't hesitate to chat with each other or look at the polls or go grab a coffee or a tea, and see you soon. Welcome back, everyone. I hope you had time to take a little break. So we will now move on to the first use case of the day, which is a presentation by Giuseppe Aulicino. So welcome, Giuseppe, and whenever you want, the floor is yours to start presenting your work.
Hello, thank you. Good morning. And I'm Giuseppe Aulicino. I'm member of the oceanography team at the Partenope University of Napoli in Italy. And today I'll give you a brief presentation about our study using high-resolution glider observations in the Algeria Basin for the assessment of two Copernicus Marine Service products. Okay, it's a bit low. As you know, knowledge of the vertical structure of the physical and the biochemical properties of the ocean is crucial to estimate primary production and ocean health and to contribute to the objectives of the EU mission about restoring our ocean and waters. In this context, the chlorophyll concentration represents an excellent proxy for phytoplankton biomass, offering the opportunity to be monitored through several in situ and remote sensed approaches, as Kenten showed before, such as satellites, models, in situ observations from ship and from autonomous vehicles. All of these provide an important contribute to this goal. However, sometimes some of them do not resolve completely the finer temporal and spatial scales which are usually needed to understand the ecological processes. In this context, the autonomous underwater vehicles, such as gliders, can help to reach this goal, providing observations at a very high resolution along the water column, usually from surface to 1,000 or 2,000 meters depth, which can be very useful to assess model reliability and eventually understand to which extent different products can be used or not. In particular, in this study, we present a quantitative comparison between the glider observations collected between 2014 and 2018 in the framework of the Abacus project. And you can see all the monitoring lines on the right figure, and two daily collocated outputs from Copernicus Marine Service products, which are the global reanalysis and the Iberian Biscay Ireland Regional Seas Ocean reanalysis, which are listed in this slide. A total of 14 glider transects were realized between Mallorca and the Algerian current, as you can see, and each mission had an average duration of only 25 days, but was mainly carried out during fall or spring season. But however, it resulted to be a useful data set for our purposes. Since we compare data sets that differ in terms of both methodological approach and spatial and temporal resolution, and also synopticity, statistical information has been used in this study to provide a kind of quantitative analysis of the differences between gliders and Copernicus Marine Service products. Each glider profile has been compared to the collocated Copernicus products, considering only a subset of the available glider observations that goes from the surface to 1,010 meters depth. That is the maximum depth at which chlorophyll data present an interesting variability in this area. The statistical result summarized in this table shows that both Copernicus Marine Service products are very well correlated with the glider potential temperature measurements, are well correlated with salinity, but not the same is found for chlorophyll concentration. In particular, this information is reported in the Taylor diagrams on the bottom of the slide, which help to quantify the degree of correspondence between the model and the glider information in terms of statistic descriptors. In particular, the closer the Copernicus Marine Service point are to the horizontal axis, the better the correlation between the model and the glider data is. In this diagram, you see the global analysis in red and the Iberian Biscay Ireland regional reanalysis in blue. And as you can see, for example, for potential temperature, both models have a very high correlation coefficient, so about 0.96. Lower but acceptable correlation, about 0.67, are found for salinity, whilst very different statistics are reported for chlorophyll concentration with global reanalysis, that are completely unable to reproduce the collocated glider in situ observations. On the other hand, the regional products agree only in part with the glider measurements with a 0.55 correlation coefficient. This large discrepancy may be mainly ascribed to the different spatial resolution between the chlorophyll products. For global analysis, I remind you that is at 1/4 degree. For the regional analysis at 1/12 degree, which is a significant difference when comparing to glider data, which are at a resolution ranging usually between 2 and 4 kilometers. Of course, we use the daily products for both the three products. Okay, these findings suggested us to pay more attention to the variability along the water column in order to understand where is the problem, and additional correlation analysis were developed at selected depths, as you can see in this slide, which are considered between 1.5 and 108 meters. Generally, the Copernicus Marine Service potential temperature and salinity products have similar performances when compared with the glider measurements. As for potential temperatures, you can see in yellow and orange, respectively. Both outputs from Copernicus products have an excellent correlation with the glider observations, especially in the first meters, that is from surface to about 30 meters. Then this correlation, let's say, slowly decrease, moving to deeper levels. On the other hand, as for salinities that you can see in blue and light blue, if an opposite behavior is found with the lower performances at surface than in the deeper layers. As for chlorophyll concentration, as expected, very different behavior is found between the two Copernicus Marine Service products, with only the Iberian Biscay Ireland outputs which are able to reconstruct part of the glider observations and only in the very surface layer. For both models, you can see that there is a large change in the correlation between 30 and 60 meters, and this let us argue that probably there is a problem with a not completely correct simulation of the mixed layer depth that corresponds to the depth at which the maximum chlorophyll is usually observed. And of course, this may have important repercussions on the modeling of the chlorophyll distribution. If you see, we have a problem at the mixed layer depth also for potential temperature that, as we said before, until 30 meters show excellent correlation with in situ glider measurements, but after 30 meters, we have a decrease of this correlation that is quite important. These discrepancies are also evident in next slide, is coming, where we present the, yeah, too much. Okay. These differences are evident in the latitudinal sections of the Algerian basin, always between 0 and 100 meters, which are provided for the three datasets along the glider track between Majorca and the Algerian current. If we focus on chlorophyll, in this example from October 2015, you see that there is an evident signature of its concentration maximum at about 40 to 70 meters that is not viewed in the global reanalysis and is only partially found in the regional products, where the magnitude and the local maxima are generally 3 or 4 times less than what is found in the photic zone for the glider measurements in the first column. So, in very summary, we can say that from this analysis, the Copernicus Marine Service products that we analyzed show a good ability to capture the general picture of the Algerian basin in terms of both physical temperature and salinity, even if we have problems along the water column, especially below the mixed layer depth. As for chlorophyll concentration, there are important differences in terms of both magnitude and the vertical distribution between Copernicus Marine Service products and the glider in situ measurements. And in general, the Iberian Biscay Ireland daily simulation present higher linear correlation with the concurrent glider than the global reanalysis. This difference may be due, as I said before, to the mixed layer depth representation in the Copernicus model service products. As for figure step, please consider that this is only a preliminary study and additional glider data must be analyzed to improve and confirm these statistical results. The full analysis is reported in the paper that is available on the program on the program page of this webinar. And in particular, consider that we have additional glider surveys that were realized by Abacus team always in the Algerian basin after 2018, so that we have now 10 years of high resolution glider observations available for scientists, careers and students who are interested in their analysis and exploitation, such as the comparison to these, but also to other Copernicus Marine Service products, to the Argo floats that Kenten showed before, or are available to assimilation into regional models about the Western Mediterranean Sea. Of course, whoever is interested in a collaboration on this is warmly welcome and can contact me to discuss ideas and data sharing also after the webinar. And that's all from my side. Thank you very much. Just in time.
Thanks a lot, Giuseppe, for your nice presentation. So, as you said, we put the link of your paper available for everyone to have a look at, and your PDF presentation will also be shared. So we have one question for you for now.
Yes, please.
Okay, so the first question, as the chlorophyll A distribution is mainly on mesoscale and submesoscale, and the model was in 12th of degree or 4th of degree, how do you address this difference to perform this comparison?
Yes, of course, this is a problem, and the comparison was made on a statistical analysis, so that we moved to the, let's say, to the larger scale, unfortunately, because we are conscious that the glider can observe mesoscale, submesoscale, but also fine scale that the models cannot, let's say, resolve. However, it's a preliminary, as I said, statistical analysis that was just to evaluate several Copernicus Marine Service products, and it was the reason why I'm presenting here is I hope that someone would go deeper into these differences and maybe address this difference and perform a comparison with much more dedicated, let's say, interpolation or statistical upscale for comparing the three products. Of course, in other studies from me and my group, you will see that we address a different approach than just statistical analysis on the entire data set to resolve these, for example, in case of the presence of eddies or filaments coming from the Algerian current into the Balearic area.
Okay, thanks a lot for the answer. So we will go to the next question. So still about the chlorophyll. So great study. Why were the service products global and IBI mismatching for chlorophyll A?
Well, actually, I could not say mismatching, but it's as I said for the previous question, it's a problem of scales. I mean, probably if you are interested in studying long-term evolution of the chlorophyll A concentration in the Western Mediterranean Sea using the Iberian B scale, probably better than global reanalysis, you are fine. If you are interested in studying a mesoscale event, such as an eddy or a filament or a specific monitoring line, as we did along the glider track, it's of course a problem of scale. I guess that these products must be improved and compared to several products to obtain this. And one more thing, please remind that this study is from 2021. So global Copernicus Marine Service data were accessed in 2021. I don't know if an improvement has been provided in the last 3-4 years. So we should check this too.
Normally updates are made regularly, but I wouldn't be able to tell you the new scales and stuff like that. But yeah, it's regularly updated, of course. So, a general question, maybe if
Okay.
you know which, yeah.
Yeah, actually, the glider is an autonomous underwater vehicle. That's wonderful because it means that I deploy it into the water just few nautical miles from the port of Palma de Mallorca, and then I can pilot it from here, from my desk, and in collaboration with the SOSIB glider facility, we deployed this glider with a Zodiac ship boat. It's not a ship, it's a boat. Just when we put into the water, then it was diving from surface to 1,000 meters depth until the Algerian current border without entering the Algerian economic area. And then it came back autonomously to Mallorca.
It's really practical to do not need to pilot the Argo floats.
Yeah.
So, thanks.
But actually, the Argo floats goes where it wants. I mean, where the currents send it. Otherwise, with the glider, we can pilot it. And for example, if we find a mesoscale eddy, for example, from Copernicus Marine Service satellite products that Kenten showed before, we can say, okay, go there, please, and check the characteristics of this eddy.
Yeah, exactly. Thanks a lot. So we have two similar questions about the difference in chlorophyll A between glider and the Copernicus data. So, and also, have you compared the global and ABA data before comparing each of them with the glider observations?
Yes, and actually the IBI data looked more reasonable to us before any comparison with the glider measurements, but of course we compared without any prejudice the two products with the same statistical analysis to the glider observations, and full details about the differences can be found in the paper. Otherwise, I'm going too long for the answers.
Thanks a lot. So we'll
And
have time.
of course, in the paper you can find the cruise by cruise differences in different seasons for different profiles. So it's much more detailed than the general picture that I presented here.
Yeah, of course. Thanks again. We have time for two more questions, I think. So this one being, do you use Power BI tool for data analysis here or statistical analysis?
No, only statistical analysis to this work. It's a preliminary study, but any suggestion is welcome if someone wants to help and collaborate, of course.
Okay, yeah, So they will be able to use their email address also with the PDF presentation. Thanks. Okay. So one last question, a more general question. When looking for habitat sustainability or preference correlations of marine mammals and incorporating chlorophyll in the model, which data input would you recommend?
Okay, that's not an easy question.
No.
To answer to this question, actually, in the recent cruises with the gliders, we included an passive acoustic sampler on the glider in order to correlate the chlorophyll distribution and generally the biochemical information collected by the glider with the marine mammals acoustic signals in the area. Just to understand if chlorophyll is actually an indicator, a clear indicator, not only of biomass and the phytoplankton, but also of marine mammals' presence and behavior. As for Copernicus Marine Service products, I don't know all the products, so I cannot recommend a specific product, unfortunately. We can work on this again.
Yeah, thanks again. I don't know all of the products either, so it's a hard job.
Yeah.
But thanks again. Well, thanks again for your presentation.
Thank you very much.
And the questions. We have a few unanswered questions, but I will share it to you if you want to answer them. So thanks again, Giuseppe.
With pleasure. Bye.
Thanks. So we will move on to the next use case. So for Georgios, so welcome. And whenever you want, the floor is yours to start your presentation about your work.
Thank you, Gail. Good day, all. My name is Georgios Sylaios from Demokritos University of Thrace. I will present to you the efforts we are doing in terms of operational modeling of oil spills in the North Aegean Sea, as they are forced by real-time MyOcean forecasted products of Copernicus Marine. So, okay, let me use my slider. And this is a time series diagram which shows that over the time, the number of oil spills in the global ocean have been dramatically reduced. And this is a result of the stricter regulations that are imposed mainly by IMO, the International Maritime Organization, but also due to the fact that we have considerable advancements in marine technology. So as you can see, although we see that there is a reduction in the number of oil spills do occur. And recently we have another spillage in the Black Sea, near the Sea of Azov and the northern part of the Black Sea, affecting mostly the coastline of Russia. The causes of large tanker spills are given here. As you can see, grounding of vessels, allision, collision, and failure of hull are the main factors affecting the accidental release of oil in the marine environment. And as you understand, the impact of oil spill is severe. The oil spill is highly toxic, affects immediately the quality and degrades the quality of the marine environment, especially the most vulnerable parts, the most vulnerable components of the ecosystem, like the trophic web, the sediments, the coastline, and ultimately the humans. Several socioeconomic factors are affected by oil spills like tourism, fisheries, and aquaculture. As soon as the oil reaches the sea, we have a series of physical and biogeochemical processes which are affecting the fate of the oil spill. The physical processes are mostly determined by the wind, the waves, and the currents. The biogeochemical processes are affected by water temperature, but also by the nutrients which exist in the marine environment and the concentration of microorganisms here you can see that the most important physical processes are the spreading, the advection of the oil spill, mostly to the direction of the wind, and the dispersion of the particles. And then we have biogeochemical processes like evaporation, the emulsification, dissolution, sedimentation, photooxidation, and biodegradation. So these oil weathering processes are not affecting the oil spill at the same time. Initially, we have mostly spreading, evaporation, dispersion, and emulsification and solubility affecting are the most critical oil weathering processes which act at the initial stages of an oil slick. And then in a more long term, we have photooxidation, biodegradation, and sedimentation, which play the major role in determining the final fate of the particles of the oil. This is the area of interest. We are working mostly in the North Aegean Sea, and especially the northern part of the Aegean Sea, which is called Thracian Sea. And it's an area which is of high risk for oil spills, since we have a lot of marine traffic. Several tankers cross the Dardanelles Strait, which is located over here, transferring oil from the Mediterranean to the Black Sea and vice versa. It's also a very dynamic area in terms of hydrodynamics. You see the results of our hydrodynamic model for the North Aegean Sea, and you see that there are several patterns. As it is shown here, we have the front between the Black Sea water and the Levantine intermediate water at the south part of Limnos. Then we have the jet flow from the Dardanelles Black Sea water. And then we have a series of mesoscale eddies, cyclonic and anticyclonic, which again will affect any movement of oil in the area in case we have an accidental oil spill. This is the monitoring system, the number of sensors we have in the sea, especially for the northern part of the North Aegean Sea, the Thracian Sea. As you can see, we have a series of ADCPs measuring online the three-dimensional currents, the waves, and the suspended particulate matter. We have one surface water quality station over here near a mussel farm, which measures a series of water quality parameters like dissolved oxygen, chlorophyll, pH, and SPM. And we have two wave riders here in Alexandroupolis, which measure the wave height, the period, and the direction. And we perform regularly on a seasonal basis glider studies along the deepest part of the Thracian Sea, which is the North Aegean Trough. So we measure with a glider the physicochemical parameters like temperature, salinity, the density, and the CDOM, SPM, and dissolved oxygen. In terms of oil spill simulations, we perform multiple experiments in the area. We didn't have any major event over this period. So we have a series of simulations and experiments which are run daily in the lab. As you can see here, we force our models with the data from the Copernicus Marine data sets, the data products, mostly with the hydrodynamic data products, but also with the wave data. And we also use a series of ensembles. Okay. So we force the wind, the model, the open drift model with ensembles of winds and waves. The model is called Open Drift, and it's created by the Norwegian Meteorological Office. It has great capacity to integrate the data from Copernicus Marine, and it also has the capacity to integrate not only the forcing functions, but also the initial conditions like the density field. Here we have the opportunity to run the model, to force it with a NOAA GFS, but here we use the ECMWF forecast. And we create a series of wind and current ensembles and wave ensembles with a Monte Carlo-like technique based on the assumption that we have a probability density function of normal distribution and utilizing the error margin produced and reported by Copernicus in the metadata and the quality information documents which are coming with the data products of Copernicus. An interesting finding is here when we try to correlate the hydrodynamic field, which forces the dispersion of the oil particles. So we tried really to correlate the turbulent kinetic energy of the hydrodynamics with the Lagrangian field. And the Lagrangian field here is represented by the dispersion coefficient. We split the two parameters in the X and Y components. X is the long flow, the distribution, the axis which is constantly changes in direction as the spill changes its own direction. So it's the long flow dimension, and the Y is the cross flow dimension. So we have here in this diagram, you can see the change in the turbulent kinetic energy in the long flow direction, and the fact that the dispersion of the particles are following this field, and this is based on the forecasted Copernicus dataset. And as you can see, with this diagram and with this analysis, we are able to forecast the shape of the oil spill and give to the authorities a better understanding on how the spill, not only the trajectory of the spill, but also the shape of the spill, and optimize the response of the authorities to mitigate the spillage. As you can see, there is a significant time lag between the two. So based on the forecasted turbulent kinetic energy, we can understand how the spillage will move and what sort of shape it will have. Here you see another experiment where the spillage was released along the axis from the Aegean towards the Dardanelles, and how it hits the Mount Athos Peninsula. In parallel, we wanted really to test the capacity of machine learning models in order to forecast the wind speed and direction in the area. So we applied a series of machine learning algorithms, as you can see in this diagram here, but we were not only interested on the precision of its particular algorithm, we are mostly interested also in the computational time. So this diagram shows that although some algorithms have very low efficiency, very high efficiency and very low error margin, they are computationally intensive. So perhaps in terms of operational modeling of oil spills are not appropriate. So we can really make a trade-off between the error and the computational time in order to increase our capacity to forecast the trajectory of the oil spill and inform the authorities as promptly as possible. This work is part of the broad project, the work we are doing for the creation of the digital twin of oil spill incidents in the North Aegean Sea. As you can see, this work is comprised of several packages, independent components, which are linked all together. We have a series of algorithms that scan on a daily basis the satellite products of Copernicus, like Sentinel-1 and other satellites. And based on a library and a series of pre-trained algorithms using convolutional neural networks, we are able to identify the occurrence of oil spills and discriminate them from any lookalikes. We also have other algorithms that scan the social media. They scan based on the geotag. They are able really to understand if there are any reports of oil spills in real time. And then we have other algorithms that scan social citizen science applications for any oil spill records. If any of these event identifications is positive, then we run the downscaled models of hydrodynamics, of waves, and of the biogeochemical simulations. And then based on this data, we try, instead of downscaling the wind field in the area of interest, we use these machine learning models that I showed you earlier to develop localized wind speed and direction forecasts for the area. Then the oil spill model is run. We inform the authorities, and we use again these text mining techniques in order to evaluate the cleanup operations as they are performed by the authorities. So this is my test case I wanted to present to you today. Thank you very much.
Thanks a lot, Georgios, for your nice presentation. So it was really interesting, and we have a few questions for you. So we will go. So I think this one is a typo error, but basically it's to know if the model
Yes.
you use is free. Yeah. So okay.
It's open source. It's open source model. Yes.
Okay.
It's,
Thanks a lot.
And it's a model that can be used not only for oil spills, but also for any other particle tracking applications like microplastics, etc.
Okay, thanks a lot. And then a few technical questions. So the first one, could you identify the specific improvements needed in the parametrization of oil weathering processes for future ecological studies?
We have done a PhD related to biodegradation, and for the moment, the parameterization of biodegradation in the open drift model is a function only of water temperature. So if we wanted really, and we have done lab experiments to see whether salinity or nutrients are affecting the biodegradation, and of course the concentration of microorganisms. And we have produced some improvements in the parameterization of biodegradation, which are not yet available through the open drift algorithms, but is something that we're working on currently in order to integrate this new parameterization on the and made available to the broad audience. Thank you for this question.
Okay, thanks a lot for the answer. Yeah, this question about if the topography can cause a dispersion effect.
Topography can change the hydrodynamic field, and of course, based on that, can have an effect on dispersion of oil spill. Yes.
Thanks. This question, I was wondering how important the waves forcing are to the oil spill modeling in the area. Could you please comment a little bit more?
Very good question. I think that waves are extremely important. We have seen that, and I didn't show this today, but we have done also simulations in the case of a Syrian oil spill, which was released in 2021 from a Syrian oil refinery in the Levantine, and we have seen that the waves are, and the wave field is extremely important. And there we used again the Copernicus field and the waves produced by Copernicus. The model gives you two options. One is to use the real-time forecasts of the Copernicus or any other product, but also you can use the waves which are produced by the winds. So instead of importing the waves from another data product, you can always use the current winds or the forecasted winds, and with the function create the waves indirectly.
Okay, thanks a lot for the explanation. It was really nice. This question about the wind, which process did you use for downscaling the wind?
For the machine learning model for downscaling the wind, we used a blended dataset from the local meteorological stations and data from the ECMWF, the forecasts and the reanalysis data. And we wanted really to see whether the forecasted field of the ECMWF is as accurate as the machine learning model. So we wanted to see whether the downscaling process gives us, the machine learning process gives us as accurate data as the ones that are forecasted from the downscaling procedure. As you understand, the downscaling requires a lot of computational resources and it's time consuming. So we wanted really to speed up the process. Thank you.
Okay. Thanks a lot. Do you have any process to differentiate oil spill from a phytoplankton bloom?
This is what we are doing right now. Very interesting question. We work now on because in the North Aegean Sea, the North Aegean Sea is affected regularly by the mucilage effect of phytoplankton blooms in the Sea of Marmara, and we have another project which started a few days ago to use machine learning and CNNs to differentiate between oil spills and mucilage. So yeah, this is what we're doing.
Thanks a lot. So spot on question. Okay. Is this model something someone without a strong background in mathematics can run? I have a statistic background, not a pure mathematics background. Thanks.
I don't think so. I think it's easy to use model. There is a very nice manual, and I think is an open source model that anyone can learn quite easily.
Thanks. Good to know. So, still about the model. Is the model takes into account the mixture of oil with water, Eulerian, or is it just a Lagrangian tool?
The model takes into account the mixture of oil with water through parameterization, oil weathering process, which is called emulsification. So based on the turbulence that you have in the hydrodynamic field, the mixture of oil with water is considered. And of course, this affects the budget of oil, because at the end of the day, I didn't show it today, but the user can also have an understanding of the budget of oil as time passes. So based on the model output, you can see which parameters affect mostly your oil spill and where the oil is being transferred. For example, if you have sedimentation and the oil is moving to your sediments, or if you have evaporation and the oil is evaporated in the atmosphere, then based on the model output, you can see that as an estimate of your model simulation.
Okay, thanks a lot. So we have a lot of questions coming about the model. So I'm going to take the first general one. So general question, can we use the wave models to predict beach and coastal erosion for the next 5 to 10 years, and which area most and least affected?
Yeah, it's not, this question is not related to my presentation.
Yeah, no.
Yes, the answer is yes, of course. The beach erosion and coastal erosion is affected by the wave models. You can use Sentinel products to go back in time and see the evolution of the coastline, and of course related to the wave products and see which are the wave incidents that mostly affect the changes in the beach line, in the coastline.
Excellent. Okay, come back to more specific question. Have you compared your model with the output of GNOME and Georgios simulation? I don't know if I'm saying it right.
We have not done that in this particular test case. We have, however, a very interesting review paper with my postdoc now, PhD student at that time, Keramea Panagiota, who has done an excellent review of all the oil spill models. And you can see, if you wish to study the literature and see the different components and the different processes that each model integrates, and assess which model is most appropriate for your test case.
Thanks a lot for the explanation. Okay, we have time for a few more questions. So about the model you use, does it include wave influence in terms of Stokes drift?
Exactly.
I guess.
Exactly, yes.
Yeah.
The model has this capacity.
Okay, thanks again. So we have also a few questions about where to find the model. So it's open source on the website, if I'm not mistaken.
It's open source. If you Google OpenDrift, you will find it.
Yeah. So just to be sure. So yeah, you can find it on internet just like that.
Yes.
So I have two questions. So I want to generate seasonal variation of Forwell Yule. Please, can you suggest the best tool and how to get data? So I have two questions about Forwell Yule. I don't know if you know what this is.
I don't know what it is.
Oh, okay. So we'll put the question on the side. So this question, general question also, but model can be used in fjord, and what happens when the particular has negative buoyancy?
Yes, this is a very good question, because what we are doing now is to see the impact of stratification and mixing and buoyancy in terms of the output of the open oil or open drift model. So you are absolutely right, you can use it. Of course, it will be affected by the negative buoyancy. And you can always take the Copernicus density field and run your model. The model requires data on temperature and salinity, and the density is automatically produced.
Okay. Thanks a lot for the questions. So we don't have time for the question left, but I will put them on the side and we will provide you with an answer. So no worries. Thanks again, Georgios, for your nice presentation and the Q&A time you give us. And well, thanks again for coming with us. So we will go to the last use case of the day. So welcome, Diego. And whenever you want, the floor is yours to start your presentation.
Yeah. Okay. Okay. Yeah, just to check. Okay, good morning, everybody. I'm Diego Panzeri, postdoc working at National Institute of Oceanography and Applied Geophysics in Trieste. And I'm going to present to you the climatic projection of species distribution using the CMS variables. So some information briefly about the background of fishery and climate change and Med Sea. So we know that impact of human activity, especially especially fishing has been very significant, and many stocks are still overfishing. Looking at the projection of salinity, temperature, or other variables, we see that there is an increase of temperature, bottom and surface, and salinity, data from Real 2022, and this is very important from economic point of view, and especially for fisheries. In this context, we use species distribution models, so SDM, and we had information about georeferenced biodiversity observation, let's say presence, absence, or density in situ observation, and different geographic layer and environmental information downloaded by Copernicus Marine Service, and using different approaches and algorithm, we make a prediction in space and time of different species involved in the study. Okay. For example, so sorry, but okay. Yes, so data input. I use physical and biochemical data set from Copernicus Marine Service. In this case, the resolution from Earth-C is 1/16 degree. Each grid cell is an approximation 6x6 side, but now the resolution improved, so it's 1/24 degree. And we use data from 2 different surveys that I will show you in the next slide. And we merge information between survey and each environmental variable for each year, depth layer, and month with geodesic distance. And I split my data in 4 time windows, 2008, 2012, and so on. For future condition 2036 and 2050 with RCP scenario 8.5. And I use different environmental layer starting from temperature, surface and bottom, oxygen or nitrate and phosphate, salinity, pH or particular organic carbon, and chlorophyll. So maybe I miss one slide. Okay. The data input that I used in this study and the species distribution model. So the Euro study is the Adriatic and Ionian Sea, using data from MEDITS, Mediterranean International Troll Survey from 1991 to 2018, and the orange dots. And to Solomon data monitoring of sole in North Adriatic Sea in green triangle from 2005 to 2018, and 9 Demersa species such as hake, red mullet, or lobster, common sole, mantis shrimps, and cuttlefish, and so on. And from each survey point, we had information about presence, absence, kilogram per square kilometers of number per square kilometers. In this case, the study regarding the number of individual per square kilometers. So this the okay. Sorry, but it's slow. Okay. And as my colleague showed you before, we downloaded the data from Copernicus Marine Service, ocean products, and information about Mediterranean Sea, especially reanalysis, physics or biogeochemistry reanalysis. You can download the data in NetCDF for formats, or I downloaded data writing a code in R and download the data directly from the website of Copernicus Marine Service, and you can subset your area, in my case Adriatic Sea, but I'm working also in other part of Mediterranean Sea. You can check and you can download all variables that you need, and for different layer, bottom, surface, or the entire column water. And the approach is used. So in a world where we have interpretability on x-axis and predictive power, there are different models. In my case, I use different approaches in machine learning methods, such as random forest or gradient boosting methods, and semi-parametric and non-parametric models, such as generalized additive models or GLM, generalized linear mixed model. And finally, we developed an ensemble model, a weighted ensemble model, and we split our data set in training and test, and also our species in adults and juvenile, because we had information regarding size. And for each approach, and for each species, and for each size, we split the data in different folds, trying different combination of environmental variable and searching for the best model for each species. So just a little resume, the process is quite simple. So we have different models approaches and past, present, and future abiotic variables. We have a prediction for each time windows, and we run a mean for each time windows about prediction of distribution in terms of number of individual, and we evaluate the hotspot in terms of high aggregation density area with JP Sorgi star statistics, and we filter the data over the third quartile just to evaluate the very density area of the species and the different size. And some results about the study. Okay, so finally, we have a distribution in terms of number of individual for each species. Oh, sorry. For each species and for each size. This is just an example of the period 2014-2018, the present period we can consider. And so we have a map of distribution in terms of number of individual for each species, and starting from this map for each species and life stage, we okay, next slide. We evaluate, yes, the anomalies between density distribution of the present condition and future condition in the 2035 and 2050, futures minus present divided by present in percentage variation. And we also evaluate the hotspot presence and future condition with the Gettysburg star, as I said you before. And starting from these results of the hotspot, we evaluate the okay, too much animation, sorry. Yes, we evaluate the past, the lost, the gained area for each grid cell that we have hotspot in 2018, the last year of our time series, and clearly the future condition in this example in 2050 has a lost, preserved, or gained area for the analyzed species based on the best model and based on the environmental variable that we used. And finally, we obtain lost and gained or preserved area for each species, and until 2050, where some species are very sensitive about climate change, especially red mullet or mackerel, showing northward or west-northward shift of dam aggregation area, or lost some habitats for species such as Norway lobster, that is quite important in central part of Adriatic Sea in the Jabuka Pomo pit. And we recall that the Adriatic is a cul-de-sac, so the limits are very essential. Conclusion. And okay, so this kind of approach using species distribution model, ensemble model, many approaches and environmental variables, and fishery independent data from survey describe the best distribution of the demersal species, combining different models, and we evaluate the significant hotspot to optimize the definition of spatial fishery management. So in terms of spatial and temporal condition of distribution of the species. And we know that we recall that the GFCN, General Fishing Commission, there is a strategy for sustainable fishery in 2030. So the fishery management in the Adriatic, but also in the Med Sea is very important. There are many fishery restricted areas that could change in the future for future condition. And here are some references. You can download the data from Copernicus Marine Service about past and present condition. Now the resolution in 1/24° by Costarini et al. 2021. And you can download the projection physics and biogeochemistry data from Real et al. And CMCC data. Finally, based on sorry, I'm waiting for the next slide. Okay. So there are some products regarding these approaches with SDM and Copernicus Marine Environmental Variables in Adriatic Ionian Sea. Sorry about too heavy. Okay. Okay. There are some products about Adriatic and Ionian Sea, or I'm working on Alboran Sea and Black Spot Sea Bream, or in the Strait of Sicily. And the last one is regarding distribution of shrimps in Mediterranean Sea using random forest and Copernicus Marine Service variables. And so the time is finished, sorry. And that's all.
Thanks a lot for your presentation, Diego. So we had a bit of trouble with the delay with the animation, so sorry for that.
Yeah, sorry, my fault. Yes.
Right. It happened, so it's okay. So we have a few questions for you. So the first one, why have you used GLMA but GAM instead of GAMM? Which effects have been considered in the random component of the mixed model?
Yes, so in GAM, generalized additive models, we use the SDM TMB package, but is a sort of GAM-M, so mixed model, and that incorporate spatial and temporal random component. So I used both approach, and yes, we consider this with this model the random component of our data in terms of spatial and temporal. In machine learning approach, I used just random forest and gradient boosting method with different tree distribution, and yes. And
the model is free of charge to use and download?
Sorry?
Is the model free of charge to download and use?
Yes, yes.
Okay, just to be sure, thanks. Okay, so this question about the software you used for your analysis, was it R or Python?
Yeah. I exclusive with ARA, and for some map projection also with the QGIS, but just as a map representation. but basically I work with R, especially with the MGCV package, SDM-TMB package, and SCDF4 to download the data from Copernicus Marine Service, and all statistical analysis and models analysis with R.
Okay, thanks. Still a question about the methodology. Can you explain? So the question is a bit slow to highlight, but can you explain how you use machine learning and deep learning methods to get the best model for your work?
Yes. I apply machine learning, splitting my data in training and test dataset, fitting different combination of models in the training dataset and predicting in test dataset, and evaluate the best performance in term of RMC, root mean square error for the test dataset, or mean absolute error between observer and predicting, and looking at the best model combination, model solution for GAM, and also for machine learning methods such as random forest and GBM. I tried different combination of three, but finally we used number of three different for random forest or GBM, but yes, what I've done is splitting training test data set for different fold and running iteratively the different model to evaluate the best performance.
Thanks a lot for the explanation. So, the next question, so we have plenty of questions. How can we conduct research on a topic like this in areas with minimal fisheries catch data?
In my case, I used data derived from fishery independent survey. In my last work, I also use CPUA data derived from catch per unit for fishery dependent data, but in that case, the model didn't work very, very well. But depending of your kind of your type of data, dependent or independent, so one of the best method that I used is especially SDM-TMB using GAMS and spatial temporal analysis, and also using different differential equation in this package. So you can try this approach, and I recall that there is a paper regarding SDM with fishery dependent data by Melissa Karp in Fish and Fisheries. So maybe you can check some information about fishery catch data in that work. So
okay, thanks a lot. Okay, so then we have several questions also about. So I'm going to choose one of those. About the CMAP5 projection downscaled. So no.
No. Okay. I use data 1 on 16 degree. The CMCC future projection variables are on 116 degree. Now, in my last work, the resolution is increased, so it's 1 on 24 degree. So if you use the actually data about past and present condition on 1 on 24 degree, and you want to use the future data on 1 on 16th degree, you need some up or down scaling process, but it's not my case.
Thanks a lot. Yeah. We had several questions about the loss and gain in your study. So this one is a little bit more complete. To calculate the lost, preserved, and gained cells in models, I suppose you've chosen a threshold. If so, what kind of considerations have you done to choose it?
Yes, I considered the significant area evaluated by the Getty-Sorgi statistic that is a autocorrelation result of the high aggregation area. And no, it's just a difference of presence or absence grid cell in past, present, or future condition. Yes.
Okay.
What I've done.
Okay, thanks a lot. Okay. We also have a few questions about the type of species you encounter during your study. So this one about if you encounter angel shark.
Angel
Yeah.
I have some data regarding shark data derived from MEDITS, and I think that there are some data. I try to use SDM with shark just as a hobby, but there are some problem with zero data, rare species, so it's not so easy, especially with angel shark. There are other species such as Chilorinus or Galeus melastomus that I is a target of this type of survey, but angel shark not so much, if I well remember.
Okay, thanks. So, yeah, we have lots of other questions about some species, but I will put them on the side for you to answer after. We are doing this one, and I think we will have to conclude after. How were the datasets for marine species distribution selected? Could you talk more about how the data in the merits and salmon datasets are collected?
Yes, so the MEDITS is a Mediterranean International Troll Survey. So it's a troll survey conducted by each country of the Mediterranean Sea, except North Africa, I think. And the data are organized by DG Mare, so you have to request by a project the data. Is a standardized, random standardized survey using troll survey nets. About Solomon is conducted by CNR of Ancona, especially by Scarcella Giuseppe, is a monitoring of sole, especially for the common sole, running from 2008 to 2000 nowadays, and using dredge nets, and is also standardized. And yes, you have data, georeferenced data, geographical position, presence, absence, different species, swept area. You can calculate the index of kilograms or number of individuals. So I choose this type of marine species because they're very important from commercial point of view in the area of study, especially for fishery restricted area and essential fish habitat area.
Okay, thanks a lot for this. So we will have to stop there. There are still plenty of questions left, but I will put them on the side and provide them to you if you want to share some answers to the remaining questions. So thanks again for your presentation and the question.
Thank you.
Yeah, thanks to everyone who joined us for the presentation. So to all of our speakers and everything. And yeah, before you leave for the participant, as you know, the practical session will be Friday at 10 a.m. CET. So if you haven't had time yet, I invite you to check the full tutorials to get ready for it. So they are available in full on the event website. There is a tab at the top where you can find the Jupyter, QGIS, and RStudio section, all of them using the Copernicus Marine data. And you can download the tutorials and watch the full video demonstration of the tutorials. And when you come Friday, you will be able to ask your question to the speakers who did the tutorial. And finally, I also just want to remind you that there is a section on the website next to the Q&A. So it's reserved to the polls, and you can give us your opinion, and we would really appreciate to have your feedback on today and what we could provide in the future. So if you can take 2 minutes of your time, it would be really helpful. And yeah, so for the replays and the presentation, everything will be made available after the second day with the certificate of participation, and you will receive an email. So yeah, thanks again to everyone who joined us. Thanks again to our speaker, and have a nice end of day. Goodbye.